Hi, I'm going to talk to you about arithmetic sequences and series. I don't think everybody got to hear this explanation, so let's make sure we do. Remember we built this castle made of cards. You have here a bit of a representation of it. You can see in the first level I've got 2 cards, and then I can count that the next level would have 5 cards, and then the next one would have 8, and the next one would have 11, and the next one would have 14. Now when I write down the numbers carefully, so 2 cards here, 5 cards here, 8 cards, 11, and 14, I realize that what's going on is that for each level, I keep adding 3 new cards. So it's very easy, without having to make the drawing, to figure out how many cards there would be in the next level. In the next level, I would have 17 cards, that's right. And in the next level, I would have 20, and then 23, and so on. This kind of situation where I keep adding a number is called an arithmetic sequence. And the number I keep adding, I call it the difference. And you can always obtain the difference by taking any 2 consecutive terms and subtracting. For example, 8 minus 5 gives you 3. 11 minus 8 gives you 3. 14 minus 11 gives you 3. Another very important piece of information that I need, apart from the difference, is going to be the first term. And I call that normally A1. And in this case, the first floor, the first level, has 2 cards. And you can see that I can make a bit of a shortcut if I want by doing the following thing. Well, here I have the first level, here's the second level with 5 cards, here's the third level, here's the fourth level, here's the fifth level, and so on. And eventually I get to what I call the nth level, which is just a generalization. N stands for any number. So n could be the 100th level, or the 200th level, or the 50th level, or also the first, second, third, fourth, and fifth levels. But I want to find some kind of general thing that when I throw in the level I'm at, I can automatically obtain how many cards there are at that level. And in class you calculated this, not knowing much about arithmetic sequences and series, but many of you figured out that the answer would be 3n minus 1. Let's try. So in the first level, I get 3 times 1, because I substitute the n for the 1. 3 times 1 is 3, minus 1 is 2. For the second level, I get 3 times 2 is 6, minus 1 is 5. And so forth for the next levels. This works. We actually would write this down in the following way. We would write something like this. an is equal to 3n minus 1. And this formula here, we call it the nth term, referring that it's kind of a general term. So I can figure out, I can just tap in the level I'm at by substituting the n, both n's, and then by operating, I obtain the number of cards in that level, be it the first one, or the second level, or the third level, or the fourth level, or the fifth level. I can always obtain how many cards do I have at that level. There is a formula in your formula booklet which allows you to obtain this very quickly. This is what it looks like. So this formula here allows you to calculate the general term of the sequence. So for example, in the exercise we were doing, remember the first level had 2 cards, and the difference, the number of cards I was adding per level, was 3. If I substitute, I would get an is equal to 2 plus n minus 1 times 3. Now I can operate this. Remember, when I have a parenthesis multiplying a number, I have the 3 multiply the n first, but then the 3 must also multiply the minus 1. I would therefore obtain an is equal to 2 plus 3 times n, 3n, minus 1 times 3, minus 3, and hence I can obtain exactly what we had deduced in the first place. Now, this formula applies to any type of arithmetic sequences and series, not only card castles, but any kind of exercise. Here's another piece of information though. Here is an arithmetic sequence, a very simple one. It's completely different though, in the sense that the difference here is not 3. The number I'm adding to go from one term to the next one is simply 1. And the first term is actually 1. So if I substitute my formula, I'm going to obtain 1 plus n minus 1 times 1, and I simply get the general term is equal to n, which makes sense because in the first position I've got number 1, in the second position I've got number 2, in the third position I've got number 3. These are all sequences. Now there's something else, you've seen it, we called it series. So what are series? Series are the same thing as a sequence, but instead of having these little commas to separate the values, I actually add a plus sign. So I'm going to actually add the numbers. Now you can go for it and just do 1 plus 2, 3 plus 3, 6 plus 4, 10 plus 5, 15, etc. But that gets very difficult once the list of numbers gets longer or the numbers get bigger. So here's a nice little trick. If you take the first number of the sequence and the second number of the sequence, you realize that if you add them, 10 plus 1 is 11. If you take the 2 and the 9, that also adds up to 11. If you take the 3 and the 8, that also adds up to 11. And so do the 7 and the 4, and the 5 and the 6. So in total, I have 5 pairs of numbers that add up to 11. So very quickly, if I have 5 11s, I have 55 as the result of these sum. Now this is a very useful trick, and the way we're going to apply it in any arithmetic series is we're just going to look at the very first term and at the very last term, add them together, figure out the number of terms we have, in this case we have 10, divided by 2, that's how we get the 5, and multiply. Now there is a formula for that. Here it is. So for example, if I want to know in my card castle, remember my card castle? How many cards do you need for 10 levels? Well, the 10th level will have 3 times 10 minus 1, well that's equal to 29 cards. The first level has 2 cards. So I can figure out how many cards I need for 10 levels by using the formula. The sum of all the cards in all the levels is going to be the number of cards in the first level plus the number of cards in the last level, that's the 10th level, multiplied times the number of levels, and all of it divided by 2. Once I operate this, I'm going to get 2 plus 29, that's 31, so 310 divided by 2. So the total amount of cards I need to do 10 levels is going to be 155. And that's much easier than writing down the whole sequence and adding together. I hope this helps you do the exercises on arithmetic sequences and series. I'll see you next time. Goodbye.